We can use differentials or linear approximations to help us estimate square roots of functions instead of using our calculator. For instance, if you're asked to use differentials or linear approximation, remember that f of x plus delta x is approximately equal to f of x plus f prime of x delta x, or dx. So this is our linear approximation formula that we are going to use. Now how we can use this, one example is if I want to find the square root of 16.5 and I want to use differentials or a linear approximation formula to estimate the square root of 16.5. Well, in this case, we know our f of x is the square root of x. If we're thinking about this, our x could be 16 because we know what the square root of 16 is, and our delta x is 0.5. So in order to use differentials, I've got to come up with f prime of x dx. So if f of x is the square root of x, then we know that this is the same as x to the 1/2. And f prime of x is then going to be 1/2 x to the negative 1/2, or 1 over 2 square roots of x. If we evaluate using linear approximation or using differentials, remember we say this is going to be equal to f of x plus f prime of x dx. In this case, we're going to have f of x, which is the square root of 16, plus 1 over 2 square roots of 16 times the differential of x, which is 0.5. And so this is going to be equal to 4 plus 1/8 times 0.5, which is approximately 4.0625. So that is an example of how we can use differentials or linear approximation to estimate the value of a square root without using that square root function of our calculator. And so I want you to work on page 234. I want you to do 45, 40, we'll just do 45 through 48. Do not use the square root key on your calculator. If you have a quiz or a test on this, I will be able to tell whether you used the square root key or whether you approximated using differentials.